think we're live now, hopefully. Hello everybody, welcome to the OneClass channel. My name is Millen and I am a software engineering student at Carleton University in Ottawa, Canada. Today I will be going over some commonly asked mathematics questions at both the high school and college levels. And if you need some homework help or some tutoring, check out the links in the description below. Cool, so let's get it moving on this mathematic magic. So the first question that we will be dealing with today is the integral of cos squared x. So I'll write down our little question here. Oops. I'll just make my pen a little thicker. So the integration of cos squared of x with respect to x. Now, typically when you see integration problems and you see stuff like cos squared and such, typically it's a good idea to think about our trigonomic identities, because they can definitely help give us an easier integral to solve, because this by itself is kind of tough. So one identity that I think could be useful is that cos squared of x is equal to, I think it's here, yep, it is 1 plus cos of 2x, I believe. Yep. Over 2. Cool. So if we try to take the integral of the cos squared x on this side, it is the same as taking the integral of this thing here. And in my opinion, taking the integral of what's on the right side of this equals is going to be a little bit easier to do than the left side. So let's rewrite our integral so that we're taking the integral of this instead of the integral of cos squared x. Okay, so we have the integral of 1 plus cos of 2 times x divided by 2 dx. Awesome. So given this, we know that we can actually split this into two terms. So we can divide, you see how the top is 1 plus cos x? 1 plus cos 2x. We can rewrite this as the integral of 1 over 2 plus cos 2x over 2 dx. And actually, even easier, we can factor out the the divide by 2, and we can pull that even outside of the integral. So that might be even easier. So it'd be 1/2, factoring out the 1/2 outside of the integral. So it'd be 1 plus cos of 2 times x dx. Okay, cool. We know that a nice rule with integrals is that if you are taking the integrals of something added with another thing, that is really the same as taking the integral of them individually and then adding them together. So we can further rewrite this as this is equal to 1/2 the integral of 1 dx plus 1/2 of the integral of cos 2x with respect to x. Okay, nice. Now, this should not feel as difficult as it did before when it was just cos squared of x. Okay, so let's do the first term, the integral of 1 with respect to x. So we know that the integral of 1 is simply x itself. And that makes perfect sense because if we take x and we take the derivative of x, that should give us 1. So yeah, makes sense to me. Equals x plus, or 1/2 x. Don't forget that 1/2. If you forget those coefficients in the front, you're not going to get the question right. Cool, so let's do our second term. Our second term is 1/2 times the integral of cos 2 times x. So the integral of cos 2 times x is, well, let's think about it. We know the derivative of sine is going to be cos. And if we have like a function inside of the argument to sine, that means we will have to multiply the entire derivative with the derivative of the internal of the argument. So here, and then the argument is going to stay the same. So I'm actually going to draw this to this side. Like we know that the derivative of sine 2x is going to be equal to 2 times sine x, or times 2 sine x. That's because, like, whoops, that should be cos, actually. I'll erase that real fast. And the reason we do that is because the chain rule. So because we have a composition of function, one function is like the function 2x is the argument passed to sine x. We need to take the internal derivative of that and multiply it out. But we don't have cos 2x. We have we don't have 2 times cos 2x. We just have cos 2x. So what if we I'll erase these and move them a little bit to the right. So if we had actually I'll rewrite this as, what if we were taking the derivative of What if we were taking the derivative of 1/2 d over dx? If we take the derivative of 1/2 sine 2x, that means when we take the derivative, the 2 that we have to multiply it with because of the chain rule, that is going to get neutralized with the 1/2 term, and our result is going to be 1/2 times 2, because that's the internal derivative, times cos 2x, which is just equal to cos 2x. That's because the 1/2 and the 2, they neutralize each other. So they just become multiplied by 1, and we don't really need to write that because multiplying by 1, well, that's just multiplying by 1. All right, cool, that's beautiful. So we basically know that if you find something where the derivative of it is what you're looking for, that means we've basically found the integral. So we still need to keep this 1/2 term, this 1/2 term. So 1/2, and we found that our integral of cos 2x is just something that you would take the derivative of to get it. And we know that the derivative of 1/2 sine 2x would give us cos 2x. So within the bracket here, we're going to put 1/2 sine 2x. Okay, cool. That's great. Now we can just expand out, like we can multiply the 1/2 into here. So we'll get 1/2 x plus 1/4. So the denominator 2 here multiplies the denominator 2 here. That becomes 1/4. Well, I mean 1/2 times 1/2. That's a half of a half. That's a quarter. So makes sense to me. Multiply that by sine of 2 times x. And that is equal to the derivative of cos squared x dx. And that would be our final answer. Ain't that neat? So let's see if the solution that we have here is agrees with us. Yep, we found the derivative of 1. That's just x on its own. The derivative of cos 2x. Yep, they found it to be 1/2 sine x. Oh, see, I made a rookie mistake. We need to include our constant of integration. So let's rewind here. Every time we integrate, we need to remember our constant of integration. And the reason why is, let's say we're taking an integral and then another integral, so a double integral. If we don't have the constant of integration, that means we will lose one of our terms, and that is absolutely not acceptable. So we always need a constant of integration. That's the plus c term every time we do an integral. So, you know, don't be like me and forget that once, because you will have if your constant of integration is not present. So with the constant of integration, we can say that is the integral of cos squared x dx. Looks good. And I guess with their answer, they factored out 1/2 from here, but it really means the same thing. So verify solution. We know that the above solution is correct. Awesome. So we can move on to the next question that we have on the menu.